Welcome back, everybody. This is the review for Chapter 11, the last video I will have to do this year. Let's go. Let's go. The last video. All right. So Chapter 11, our last chapter of exam review. Again, I would strongly encourage you to get out your note card. Because remember all those formulas that we learned at the beginning of Chapter 11? Yeah, that's something you definitely should put on your note card. So, I was going to write them all out, and then I thought, why not? Why not I just get out that little piece of paper that I'd had? So this is the formulas. These are the formulas. So if you want to write them down, go ahead. Whoa, don't do that. If you want to write them down, go ahead and write them down, but you don't need this compound interest formula. Okay? I'm going to give you a moment. I know this is going to take a minute. I'll write them on the board too so we can reference them as we go. Because we'll need them as we do the problems here. Hey, look at this. I found a note card. I didn't even think I had any note cards. Does anybody need a note card? Hi, Taylor. How's it going?
It's going great.
You need a note card, Taylor?
No.
You got one?
Yeah.
Okay. Yeah. R means the rate at which things are growing. Anybody else need a note card? Would that be first, Dad? Mr. Ruby.
No, minute, huh?
Yeah. Hey, yes, we did. Boy, David.
Oh, yeah. After my heart to heart.
Exactly. Yeah. Not that.
Glad
I know.
get back.
Exactly. Really feel like you're
Changing lives.
No, P stands for principal or starting value. P stands for starting value. Did anybody else need a note card? Yep. Dang. You can do markers next year. Exponential row is 1. Oops. A times 1 plus r to the t. Exponential decay. Y is equal to a 1 minus r to the t. And then half-life. A is equal to P times 0.5. All right, so these are all the equations that we learned in Chapter 11. This is what should be on your note card. Please, please, please put this on your note card. Because it's going to be very important that you have these for yourself. Let's talk through what everything means here. In terms of the arithmetic and geometric sequence, what does A sub 1 mean? The first term in the sequence. in your arithmetic sequence and your geometric, what does the n mean? The term you're trying to find. So like maybe the 7th term, 7 is n. You're trying to find the 10th term, 10 is n. Now, D and R are the rates. I don't want to use the word rate. It's how much it's going up, right? Or down. For arithmetic sequence, what am I doing? I'm constantly doing what? Multiplying? No. Adding, right? Arithmetic sequence is adding. Geometric sequence, that's multiplying. So the rate at which I add, the number at which I add is D. The number at which I multiply is R. That's your rate of change. For 3 and 4, notice that for 3 and 4, the exponential growth and exponential decay, the exact same equation with one key difference, the plus or the minus. Okay, the plus or the minus. So it's little a, which is our beginning value, times 1, either plus or minus the rate. And I should have to give you a percentage rate raised to the t power. And then we have our half-life, and then r is my rate, and t is my time. I did today. And then I have my half-life. Now, be careful with half-life. P, that capital P, you could write it as a to little a. That's your beginning value. And then times 0.5, half-life, raised to the t power. Now, be careful for t. You might want to make note of this for yourself. T is the number of half-life cycles that it will go through. So say the half-life is 2 years, and I'm looking at it over the course of 10 years. Half-life would be, my t value would be 5 in that case. It's going to go through 5 cycles. 5. Okay? All right, so that's the beginning part of chapter 11 in a nutshell. Yeah?
For the exponential, how do you make the one a percentage like the ratio?
Move it 2 decimal places to the left. It's going to give you a percent, and you got to turn it into a decimal by moving it 2 decimal points to the left. So this is the beginning part of chapter 11. The second part of chapter 11 is the stuff that we just got done with. It's all that simplifying radical stuff. Okay? We learned how to add, subtract, multiply radicals, and divide radicals, and simplify them as well, and solve equations with them. So let's get to it. Let's do some examples, shall we? All right, what is the 9th term in the arithmetic sequence? What is the 9th term in this arithmetic sequence? I didn't even need to tell you that it was arithmetic. You should know that it's arithmetic. Why? Because what am I constantly doing? Subtracting. I'm constantly going down, right? By an even amount. How much am I going down by? How much am I subtracting? 2. I'm minus 2 each time, right? So my d value is negative 2. My a sub 1, what's my first term in this sequence? 3. And what's my n value? 9. That's the number I'm looking for. So I go back to my arithmetic sequence equation. I'm going to say that it's a sub 1 plus n minus 1. Now, the number I'm looking for is 9, so I've got to take 8, n minus 1. 8 times negative 2. So I go to my calculator and I say 3 plus 8 times negative 2. Negative 13. There's my answer. Yeah. No, that's fine. You can repeat it anyway. Yes, sir.
How do you get 3 plus
8? A sub 1 plus, so a sub 1 is 3, right?
Yeah.
Plus n minus 1. This 8 is n minus 1. 9 minus 1. So 8. And then that's your times your d value, your constant difference. Okay, so that's arithmetic sequence. Let's do a different problem here. Let's do, Timmy sets aside $45 in his piggy bank and going to add $7 per day. What will his piggy bank be have in it after 2 weeks? Okay, so this is arithmetic. How do I know that it's arithmetic? This word right here. I'm adding each day. What's his starting value? Plus an additional $7. That's your D value. And after 2 weeks, n minus 1. N is 14 days. So I'm going to multiply it by 13 days. Going into the 14th day, I will have this amount, 14 plus 7 times 13. $136. Going into the 14th day. Yes?
How do you know it's not exponential growth?
Because I'm adding and not multiplying. And I'm not giving you a percentage rate. You know what I mean? Nothing in here is a percentage. So great question. How do you know it's not exponential? Oh, I want to do a different problem other than this. Let me get this one out again. Whoa, that was weird. Turn that inside. What is the seventh term of the geometric sequence starting with a common ratio of 3? Seventh term in a geometric sequence starting with a common ratio of 3. All right. Starting with 2 and a common ratio of 3, excuse me. So that means a sub 1, that's a 1, is 2. My r value is 3, and my n value is 7. Okay. So my geometric sequence says a sub 1, 2 times r to the n minus 1, 7 minus 1. So 2 times 3 to the 6th power. 2 times 3 to the 6th is 1458. 1,458 is my 7th term. Okay. All right, let's do an exponential growth or exponential decay problem. The population of Lavericktown is 11,256. Okay, 11,256, and is increasing at a, what should be my percentage? 4% rate. What will the population be? In 6 years. Assuming the pattern continues. The population is 11,256, and it's increasing at 4% rate. What will the population be in 6 years? What will the population be in 6 years? This is exponential growth. How do I know that it is exponential growth? Because there's a percent. There's a percent. That's exponential growth. How do I know it's growth and not decay? Right. It's going up and not going down. It's pretty simple. Use the context clues to tell you whether it's going to be exponential growth or exponential decay. All right, so we know it's exponential growth. So we can say that it's y is equal to little a. Now, what's little a in this particular problem? Yeah, our original starting value times 1 plus what? 0.04. Good. 0.04 raised to the 6th power. Don't say 0.4. That would be a 40% growth. I want a 4% growth. So this is 11,256 times 1 plus 0.04 is 1.04 raised to the 6th power. So over the course of 6 years, population will grow to 14,242 let's round up. 40, actually no, 5 and below. Let it go. 14,242 people. I wouldn't take off for rounding.
So say it was something like 17%. Would you like that at 0.07?
0.17. 0.17. Yep. So when I'm like putting it into the equation, it'd be 1.17. Yes, sir.
Would you have like a 300% growth rate?
Well, I mean, you could, you know, but then it would.
C past 100%.
Yes. Yeah, because that just means that, you know, like if the population is 2 on one day and then it's 5 the next day, you have an over 100% growth. You know, 100% growth would be 2 more. And then, so anything beyond that would be more than 100% growth. All right. So that's the beginning part of chapter 11. Let's talk about the ending part of chapter 11. Again, I want to see us writing these down as we go. All of the directions here are just to simplify. And this should be a review over the stuff that we had just done. All right, the square root of 60. The square root of 60. Remember, that's a factor tree. That's 2 and 30, 2 and 15, 3 and 5. So we buddy up with the 2's. So that's 2 radical 15. There's my answer. 125x to the 5th. Okay, that's 5 and 25, which is 5 and 5. Buddy up with the 5's. I've got a 5 coming out. Be careful with the x to the 5th. Draw it out. Buddies and buddies, I've got 2 coming out with 1 5x staying in. Got a lonely 5 in. I've got a leftover 5 on the inside, and then a leftover x on the inside as well.
That makes sense. Right?
So 5x squared, radical 5x. Remember, anything that doesn't have a buddy stays on the inside. Anything that doesn't have a buddy stays on the inside. All right, let's take a look at the next couple. As these are right now, I cannot add or subtract them because they do not have like radical terms. So let's put them into like radical terms. Let's do one of these. Which one do you want to do? The adding or you know, let's do the subtracting one. I'm sorry. I know some of you probably already started writing it down. I'm going to do the subtraction one on the right side. 5 radical 12 minus 2 radical 27. So we break down radical 12. What's the total that we get on that radical? 10. Right? The 2 coming out, the 5 that's already out there makes a 10 total. We break down 27. We pull out a 3, leaving a 6 on the outside, right? The 6 is because of the 2 that was already out there and the 3 that came out multiplied together to get a 6. So what's my final answer? 4 radical 3. Remember, leave the radical 3 on there. Leave the radical 3 on there. The 2 coming out times the 5 that was already out there. That's the thing. Okay. Let's do each of these. Okay, we distribute this in. So So that'll get us a radical 3 times a radical 2 will get us a radical 6. Plus, radical 3 times radical 3 is a radical 9. Oh, so that's not too bad. That's just radical 6 plus 3. That's it. Not bad at all. Yeah. Yeah, if we broke it down, it'd just be 2 and 3, and there's no buddies. This second one here, I would try to reduce the fraction, but does 2/7 reduce? No. So that means I need to do this thing where I rationalize the denominator. I take the denominator and multiply it top to bottom. So that gets me the square root of 14 over just 7. That's it. That's all I can do. I would try to break down the square root of 14. But it just goes to 2 and 7 and there's no buddies. So we're done. Okay, I really need to point out how to do problems like this. Because this was a huge issue. A lot of you guys that missed a lot of points on this past test, it's probably because you didn't solve these equations correctly. You need to square both sides once you get the radical isolated. You know what I had people do? Everybody look up here. I just had people like just subtract 2, divide by 4. Like just ignore the radical sign. Like it was just not there at all. Like that was like a major thing. A lot of people did that. Don't do that. Don't be that guy. What gets the radical to go away? Squaring the opposite side, right? You have to square the opposite side. 4x plus 2 is not equal to 4, but 16. I square the entire equation. That gets the radical to go away on the left, and 4 squared is 16 on the right. Now I subtract the 2. Now I divide by 4. So 14 divided by 4, that's a decimal. 3.5. Now, for this first one that I got on the left side here, I do add the 7 before I start squaring. Because that's not underneath the radical. I have to add the 7 first, and then I get the square root of x is 2. Now I square it to get the 4. Okay. And our last problem. What do you do if you've got square roots on either side? This is when I just take them off and ignore them. Why is that the case? Well, because if I square this entire thing, that just removes the radical on both sides. So this just gets me a 2x minus 1 is equal to 3x plus 4. And that, we subtract the 2, we get rid of the little guy. Negative 1 is equal to x plus 4. We subtract the 4, we get negative 5.
Squared on the outside and anything to do with it. It just goes away.
Just goes away.
Oh, because
Yeah. Questions about that? Okay, I'm going to stop the video here. Last video. So long, everybody. See you next year.